Hi everyone, welcome to my channel, Maths Made Easy with Terry in 10 minutes. So we're going to talk about how do we find the determinant of a square matrix, okay? And I've talked about the types of metrics earlier, and one of the metrics types I mentioned was the square metric. So it's very important that you review previous videos and try to understand that before proceeding forward, all right? Now, before I proceed, don't forget to like, share, and subscribe. And if you've not clicked the notification bell, I don't know what you're waiting for. Please do so that when I post new videos, you'll be the first person to know. All right, so the determinants of the metrics. I'm going to talk about the square metrics, I beg your pardon. I'm going to talk about this in three parts. The first part, I'm going to do an introduction. Then the second part, I'm going to talk about the 2x2 metrics and how to find determinants of a 2x2. And the third part will be how do you find the determinant of a 3x3 matrix. At the moment, I'm going to stop because of this level. I'm going to stop for a 2x2 and a 3x3. I'll go more than that. But after that, later in my subsequent video series, I'm going to talk about the higher order of matrices. Is that okay if I have time for it? So let's go. So the first thing I'm going to talk about is that the determinant of a matrix is a single numerical value, which is used when calculating the inverse, or we use it when solving linear equations. Subsequently, we're going to talk about how do we find the inverse of a matrix down the line, and we're going to talk about how do we find a linear equation. So, but before we do that, we need to understand how to find the determinant of a matrix. And I'm going to tell you how it's denoted. I'm going to tell you how it's defined, but because the determinant is only defined for square matrices. So if the matrix is not a square matrix, you can use it here. So, and also another thing you need to keep in mind is that when we're talking about the determinant, a matrix is said to be a singular matrix, because I talked about a singular matrix in the previous video. So a matrix has to be a singular matrix if you calculate a determinant and you found it to be zero. Okay. And also we talked about in previously I talked about the non-zero matrices, or we talked about zero matrices. So those are the words you need to get conversant with. Okay, so I'm going to talk about something like the isomorphism as well, and we'll talk about some other types of matrices. I'm going to just talk about it here. All right. So, like I said, I don't want to jump myself, okay, because I'm already excited talking about a lot of things as well. So what I'm going to do, I'm going to just write down my thoughts here. So I'll just give a quick introduction and just a reminder of what the determinant of a matrix is and what we use it for. Then in the next video, I'm going to show you how to find the 2x2 and the 3x3 matrices. Okay, so let's go. So the first thing is that the determinant of a matrix, okay, the first thing I said was that the determinant of a matrix is a single numerical value which is used when calculating the inverse. Okay, so it's used when calculating the inverse. We'll talk about how to calculate the inverse very soon, or when solving when solving systems of linear equations. Okay, so can use it to solve when solving inverse or calculating inverse or solving system of linear equation. So how do we denote matrices? So the determinant of a matrix A, how to denote a determinant? So the determinant of a matrix A is denoted like an absolute value, or you can also write it as det A. So for instance, if we have a matrix B, okay, and you found a determinant, so you're going to write it as, this is the determinant of matrix B, or you can say it as det B. Is that making sense? So that's how we represent it, okay? But one thing I need you to keep in mind, and you should not forget, is that we only use determinant for square matrices. So I've talked about square matrix. So why I told you a square matrix is a matrix that has the same number of rows and column, okay? So something you need to keep in mind. So the determinant, okay, is only defined for square matrices. Okay, so for instance, if you have a 2 by 2 matrix, you can find the determinant. But if you, for instance, have a 2 by 5 matrix, which is a rectangular matrix but not a square matrix, you can find a determinant for that. Is that okay? So we only use this when we're talking about square matrices, okay? And also another concept that I said was we also use you will notice that I'm going to talk about things like singular matrices and the concept of singular matrices and how to go about it. So it's important as well that you tend to know that also. So when a matrix is said to be singular, so a matrix is said to be singular okay, it's said to be singular if the determinant is 0. So when you solve a particular matrix and your answer is 0, when you found a determinant, okay, then that matrix is said to be singular. So if its determinant is 0. So for instance, if we have matrix A, okay, and then we found the determinant of this matrix to be equal to 0. When we solve, I'm going to show you how to do that. Then we can now say matrix A is what? Singular matrix. So when the determinant is equal to what? 0. Now, but one of the things is that the determinant is non-zero. When the determinant is non-zero, if and only if the matrix is invertible. Okay, so those are keywords you need to know. So if a matrix is invertible, then we can now say that the determinant is going to be non-zero. And also we need to know that the linear map represented by the matrix is going to be an isomorphism. So those are keywords you need to understand. Talk about the invertible isomorphism. So we're going to talk about this very soon when I go to the inverse of a matrix. But as usual, I want to make note of it here so that when I get to that stage, I know I've mentioned it earlier. So the determinant is non-zero. Of a matrix, all right, is non-zero. So it's non-zero, okay? If and only if the matrix is invertible. Okay, so if and only if the matrix is invertible. And also another thing you need to know, we need to know that the linear map, okay, and the linear map represented by the matrix is an isomorphism. Okay, so these are some words that you need to get used to. But for this video, I'm not going to talk about it. I just want to talk about, just mention it here. But when we get to the inverse of a matrix, I'm going to talk about it in details. Okay. So, but in this video series, the only thing I'm going to talk about, the two square matrix I'm going to talk about. So here, what I'm going to talk about, I'm going to talk about the 2 by 2 matrix. So how do you find the inverse, sorry, the determinant for a 2 by 2 matrix? And I'm going to talk about how do you find the determinant for a 3 by 3 matrix. So I'm going to give you these two in this video series. What I want you to do, when you understood this, you can go back and read up on how do you find the determinant of a 4 by 4 matrix. So I won't discuss it here. Okay. So I'm not going to discuss this. I'll only focus on how to find the determinant on the 2 by 2 and the 3 by 3. Okay. So the next video will be how to find the determinant of a 2 by 2 matrix. So it's important that you subscribe and you click the notification bell so that when we talk about when I upload a video on how to find the determinant of a 2 by 2 matrix, you'll be the first person to know. All right. Thank you very much, and I will see you. So don't forget how we denote a matrix is very important. Okay. Don't forget how we denote a metric. So we denote it by using the absolute sign. So, and also we have a square matrix, a 2 by 2. So a square matrix is a matrix that has the same number of rows and columns. And if a matrix is said to be singular, it means the determinant is 0, okay? And also we're going to focus on the 2 by 2 and the 3 by 3, but you can also read up the 4 by 4 matrix. All right, so I'm going to see you in the next video where we talk about the 2 by 2 matrix. And please, if you have any question, don't hesitate to ask me, and I will send me an email or drop it in the comment section, and I'll get back to you soon. All right, see you soon. See you in the next video.